Hello class, today we'll be going over an example for logistic regression. In this example, we'll be using a bank loan dataset to see how we can build a classifier that can help identify potential customers who have a higher probability of purchasing a loan. Our first step would be to carry out a test train split on the dataset. Our second step would be to carry out logistic regression on that dataset. Our third step would be to carry out feature normalization on the dataset. And lastly, we would be carrying out logistic regression on the normalized data set and see if the scores improve. Okay, now going over the code. In this first code block, we're importing all the necessary modules. Then we are importing the file and looking at the columns. Now we are creating an array matrix X with just the values of all the predictors or independent variables. In this code block, we are creating an array matrix Y with just the values of the dependent variable or the response variable. Finally, we are carrying out a test train split on the data frames. For more information regarding test train split, you can refer to this article. Now we'll be carrying out logistic regression on the data. Our first step is to declare a logistic regression object. You can look up more information regarding different hyperparameters in the online documentation. Here we are creating a function that is declaring a logistic regression object, fitting the model using training data, and then evaluating the performance of the model using R-square. So test score and train score, both of these give us the R-square values for the model that we have just created. Now we'll be carrying out feature normalization to improve the performance of the model. The first method we are using is called min-max scalar, and it is used to set the values of all the independent variable columns between 0 and 1. The next method we'll be using is polynomial features, which is used to generate a new feature matrix consisting of all the polynomial combinations of features with a degree that is less than or equal to the specified degree. Here we have specified the degree to be 2. In this code block, we are carrying out the normalization on train set directly. And then in the next one, we are carrying out the feature normalization on the test set using a function. Finally, we are fitting the model again with normalized data, and we can see that the R-square values have improved a little bit.